Okay, I think it's recording now. So thank you guys for joining us today for our third event at MuleSoft for Java Developer Group. So my name is Guilherme Pereira. I'm Integration Architect of Infomentum and also part of the MuleSoft community as MuleSoft Ambassador. And today we have here in our group Alex. He will demonstrate to us how to extend the MuleSoft runtime building a circuit breaker component using the Mule SDK. So it will be a great event with a great content by Alex. Alex, can you just go to the next slide, please? So before to hand over to Alex, so all these slides and the recording will be available on the event page within 24 hours. You can send any questions and time in the Q&A session in the channel panel. If you click on the Q&A session in your channel panel, you can write down your questions during the meetup, and we will have some time after the presentation to answer your questions. During the session, I will send a link to you guys with a survey. So please answer the survey and help us to improve this meetup group. It's your feedback is very important for us. And by the end of the presentation, join us to a trivia game, and it will be our chance to win a training voucher from MuleSoft, and you can build their career. So it's a great opportunity to have in these vouchers. We will play a trivia game. I will explain and give more details by the end of the presentation. But it's a great opportunity for you guys to improve your skills and attend course with a MuleSoft instructor like Alex. So let's hand over to Alex. Alex, over to you. Thank you again for collaborating with us in this group.
Thank you, and welcome everyone to this meetup. My name is Alex Liedem. I'm a principal technical instructor at MuleSoft, and looking at the list of participants, I recognize a few names who may well have been students on some of my courses. So welcome to you. I'm a Java developer, a Java professional, been a Java developer and architect for close on to 15 years. I'm also a Java champion as well. I've published a number of books about Java and delivered training through via LinkedIn as well. So this is my Twitter account. During this presentation, please feel free to tweet using Java to Mule hashtag. So please feel free to share your experiences as we go through this presentation. I want to try and see if we can get Java to Mule trending this evening. All right, so let's see if we can do that. And you can always come be my friend on LinkedIn as well. There's my LinkedIn name. All right, so let's get started. What are we going to be covering today? Well, we have a busy schedule this afternoon, so sit back, relax, kick up your feet, and enjoy the show. What's on the agenda? Well, first of all, what is the Mule runtime? So for those of you who perhaps don't know or have forgotten, I'm going to remind you about the Mule runtime itself. Not going to take too long with that. Then I'm going to move on to what are Mule applications used for, some use cases, and then what is the Mule runtime, or how is the Mule runtime extended? So how do we actually extend the Mule runtime? What's involved in that process? Then we're going to be looking at the structure of a Mule extension. We're going to look at the entire structure. So we have a boundary, a context of the extent to which we can actually extend the Mule runtime. So we've got an overview. We're going to be looking at the anatomy of a Mule extension, so we understand, first of all, what a Mule extension looks like, which is something we're already familiar with. We're going to look at the entry point to a Mule extension and look at the configuration, the connector provider, the connection logic, the operations, and the router operations as well. Then I'm going to introduce today's use case, which is going to be the circuit breaker. Then I'm going to switch from my slides to Studio. I'm going to do a live coding of a circuit breaker router from 0 all the way through to completion, and then use in an example. So that's going to be fun. Live coding is always a bit scary because you never really know what's going to happen, but bear with me. Hopefully things will be fine. I've practiced at least twice. And then we're going to have some challenges. At the end, I'm going to share with you the code repository, some other useful resources. Then we got question, answer, and trivia at the end. All right, folks, let's get ready. So what is the Mule runtime? Well, the Mule runtime is, and this is important to know, it's a Java Spring-based runtime into which Mule applications are deployed. Okay, so we know that already, right? We're Mule developers. Perhaps we're coming from a Java background and we're not particularly sure. So perhaps this is really a way to explain what the Mule runtime is. It's a series of directories containing a whole load of Java code. As you can see here on the right-hand side of my screen here, this is what the Mule runtime looks like when you download the zip file from the website, the Mule website, and you extract it. This is what it is. It is a series of directories in which there are configuration files, there are a whole load of jar files which make up the Mule runtime. And it's into here, the apps directory, into which you actually deploy your Mule applications. But what is a Mule application anyway? Well, a Mule application is just a whole load of XML configurations that configures already existing functionality written in Java. That's effectively what a Mule application is. So when you're building a Mule application, you're providing the parameters that populate already exist, populate bean instantiations. So if you remember back to the good old days where Spring used to have a whole load of XML files and you used to have to instantiate beans with the values from those XML files. Well, that's kind of what Mule is looking like behind the scenes. Okay. But not entirely. It's a little bit more than just that. We can think about that as how our Mule applications are working. And that helps us to frame our minds for how connectors work. We got to think about that. That's what we're doing when we're creating a Mule application. We're configuring something that we've created. And that's what I'm going to do today. I'm going to create a circuit breaker and expose properties and parameters for configuration. Okay, so within the Mule runtime, there are already existing functionality, as I said. So there's for each, there's scatter gather, choice router, loggers, connectors to external data sources, and so on. And you provide the configurations to those already existing pieces of functionality. Then they're connected together in a logical order, and we call that a flow. And that flow processes data as the Mule event is passed across that flow. You can have one-to-many Mule configurations can be deployed. So one-to-many Mule configurations or Mule applications can be deployed into the same runtime. So what are Mule applications used for? Integration, essentially, that's what we're talking about. Processing data. So they are small units of integration that are designed to work in collaboration with multiple other units of integration and to produce an integration solution. That is what Mule applications are used for. It's like a middleware layer or ESB, if you're familiar with that, but it's a little bit more than just that. So when we're producing a connector or an extension for the Mule runtime, we're enhancing the functionality of these Mule applications that provide integration functionality, integration points. So how is the Mule runtime extended? Well, we use the SDK. Okay, the Mule runtime is extended by developing Java code in accordance with the framework provided by the Java SDK. This allows us to produce a Mule extension. Now, the Mule extension covers a variety of different pieces of functionality types. So you may already be familiar, if you've built Mule applications, you may already be familiar with connectors, right? A connector allows you to connect to a database, right? You provide it with the connectivity details, such as the URL of the database, the username, the password, the port, and then you provide it with the SQL query that you want to execute, and then the magic happens behind the scenes inside the connector. It connects to the database, it manages the pools, it handles the whole business of that connection. That's what a connector does. And the person who created, or the team that created that connector, well, they know how to write the Java code that connects to the database. And they've encapsulated it inside a Mule extension. The type of that Mule extension is a connector. And there are various extensions that can be created. A connector is one of those. So that a connector encapsulates that connectivity logic to that external system with which data is exchanged. So a MySQL database or SAP or SAP or Twitter or PayPal or FTP Connect, an AWS service, for example. But then we have operations. Operations are connected with connectors because the connector will connect to a database and provides the connectivity logic, but that's not enough. We need to be able to do operations in relation to that database, for example, right? We need to be able to select and delete and insert and update. So operations are written in order to provide the functionality related to that connection, okay? Then we have routers. Routers are all about routing, hence the name routers. They route messages through a Mule application in one way or another, following some kind of logic. Usually routers are some kind of implementation of an enterprise integration pattern, such as the content-based router or the scatter-gather. We're going to be focusing on building routers today. Sources also are another extension that you can create. Sources are what trigger the Mule application into action. They listen for events. They listen for an HTTP request, or they listen at the end of a queue for a message, or they listen to a file directory for a new file to be created in that directory. And they capture that information, they capture that file, they capture the body of that HTTP request, or they capture that message, and they package it up into a Mule event and pass it to the flow to be processed by the event processors in that flow. We can create sources as well. Scopes. Well, scopes are ring-fenced sub-processes within the main process of the Mule application. So typical examples are, for example, if you want to spawn a separate asynchronous thread, you can use the async scope that's already created, or you can do caching or transactions. Scopes are a way of being able to create an encapsulation of a kind of functionality that you want to apply to one or more event processes. And then we have functions, okay? Now, for those of you who are not familiar with Mule, we have within the Mule runtime our own transformation language called DataWeave that is highly optimized for the purpose of transforming data. Of course, we're talking about integration here, and obviously data is the business of integration. It's the blood that flows through the integration pipes. It's what makes integration, right? And so we have to transform that data. We have to transform that data into something that is more useful, more in the structure that we want, is cleansed, is aggregated. We use DataWeave for that, and DataWeave contains functions, but we can add additional functions to DataWeave by creating a functions extension. So to summarize, we can really extend pretty much everything to do with the Mule runtime. We can create connectors, operations for connectors, routers, sources, scopes, functions. We can keep ourselves busy all year long creating extensions for the Mule runtime. But today we're going to focus really just on routers. Now, let me put this all in a bit of context here. So this is a diagram I've borrowed from the docs.mulesoft.com website, which has a really valuable section about how to create each of the things I've just spoken about. It can contain some useful code examples. So I would recommend go to docs.mulesoft.com and search for the documentation on the SDK. I borrowed this image directly from there, but it actually provides us with a way of being able to visualize what I've just spoken about. So the components are what we actually create. So we create the components that contains the actual logic of the functionality we want to add, whether it's an operation or a source or a router. But we need to provide some configurations for it, potentially configuration providers, and also, of course, essentially parameters, because remember what I said earlier, it's very much like way back in the day when we had Spring. We would provide XML files that had properties and attributes, and those attributes would then populate Spring beans, right? Well, these are the parameters that the MuleSoft developer provides that configures the actual functionality itself. So here we go. I've just mapped from operations, could be database connector, select, delete, insert. For sources, could be a scheduler or HTTP listener. For a router, choice, scatter, gather. Scopes could be async, all or any for validation. And in terms of functions as well, data weave, again, map objects, reduce. Okay. So let's dive a little closer and let's kind of put things into a context that perhaps we're already familiar with. So if you have been building out Mule applications, then you'll be familiar with the way in which the database connector works. So the database connector has various parts to it. You need to, of course, include that dependency here into your project. Okay, so you bring that dependency into your project, and then you have various operations that you can perform against that database. So you have delete, insert, select, update, right? And you can drag that operation into your flow and configure it appropriately. For example, here I want to execute a select query against the database. So I'm just typing here select star from American. Okay, those of you that have taken the fundamentals course will be familiar with what I'm referring to here. And then on the left-hand side, we have the database connectivity. This is the configuration and parameters that are provided to allow the connectivity logic inside the connector to actually connect to that database. So we have the host, we have the port, the username, the actual database name. So when we're creating an extension, we need to think about what it is that we want, what it is that we need from the user of that extension to make the functionality that we're creating actually work. So for the database, this is the connection. That will allow us to establish a connection with the database. Then, of course, we have the operations that execute each of these different functions: delete, insert, update. And then we have the connection provider, which is actually the connection itself. So on the left-hand side here, we're providing through this interface the connectivity details, usernames and passwords, etc. That actually gets passed through to all of the jar files that are actually combined together to produce the logic for the actual connector itself. And in this particular instance, there's a lot. So C3PO is used for managing the pool. We have the commons collection that's used for dealing with, I think in this case, dealing with arrays, I think. And then we have the MuleDB client, MuleDB connector, various different pieces and bits and pieces in order to handle those connections and so on and so forth. Okay, so let's start with talking about how do we actually get the application starting. So we're going to see in a moment when I go through and I do a live demo that when we want to start to build out a connector or any kind of extension for that matter, we start with a Maven archetype. So I haven't detailed that here on the slides, but I'll give you a demo of that when we actually get through to the live coding. So what you see on the screen is the entry point to your extension. Whatever the extension is that you're creating, whether it's a scope or a router or connector, you have to have this entry point. And this entry point class has a number of annotations that are provided at the class level. Okay, so we need to annotate and provide, for example, the operations class that provides the actual operations. Okay, so we have a class that describes the operations. Go back here. Hey, these are the operations. On the left-hand side, these are the operations. Each one of these operations has an associated method in the operations class. Okay. We need to provide a way of capturing the configurations. Okay, we've got to capture the configurations. So to capture the configurations, well, there we go. This database config, this global element, well, that is constructed from parameters that are configured inside our configuration class and our configuration class. We may also have a configuration provider as well if we're creating a connector. So there may be an additional class here that we're also going to provide. So of course we have the extension has a name. So this is a friendly display name, and the XML is a bit of fun here. This is how do we want the XML to actually look? Okay, so when you're creating your Mule application, there's going to be you're going to view the XML, and in the XML, what is the XML going to look like? If you're creating an HTTP list, if you're using an HTTP requester, right, it has HTTP : and then some information. If you're creating a database, it has database : so this is what the actual XML is going to look like. You get to decide that when you create your extension. So what else can we talk about? Well, the configuration. All right, so here I'm going to be switching to an example which we looked at in the previous meetup that we did, which was to create an AWS Poly connector. So Olga presented that meetup and talked all about that. So if you want to know how to create a connector, then I refer you back to her meetup. So how do we do that? Well, basically, you need to, your global element is created in the connector. In the connector configuration class, that's where you put your parameters. Okay, we're going to have a look at that in a moment. Actually, we're not going to create a connector configuration for this particular router because there is no need to do so. But for a connector, most definitely, you've got to ask for that username and password, right? You've got to ask for that username and password. That's going to be here in the configuration class for the connector. What we're doing here as well is we're making reference to the provider. Remember, I spoke earlier in the previous slide about sometimes you might need a provider. A provider gives you the actual connectivity logic, the actual, logic for connecting to AWS or the database. That's where you've got to put it, in that provider class. So also as well, on the configuration class, you can implement lifecycle phases. This is very cool, and we'll show you how this works when we get through to actually doing the coding, because it allows you to initialize, to execute code during the initialization of the Mule application itself. So when your Mule application is initializing, you can actually execute some code. So first of all, the initialize method is executed, then the startable, and then we have stoppable and disposable. So I put them in order: first, second, third, and fourth. So when you're initializing the application, you execute this method, then startable also executes subsequently. Okay. And also as well, you can inject services into the configuration class for use in your connector or in your extension. I'm going to use the word extension. So you can inject services. So you can inject the object store manager. This is fantastic. I'm actually going to be doing that and showing you how to inject the object store manager into the extension, because we're going to be using the object store manager in the circuit router to maintain state. We have to maintain state across invocations. So the object store manager is the obvious choice for that. You can inject the transaction manager, the security manager, the expressions manager. This is used to evaluate expressions. There are more you can also configure as well, but those are the four that I think are probably the most interesting services. And then you can get access to the transactions, security, and expressions as well, and all the functionality they provide. So let's take a look at the structure of the connector provider. So if you're creating a connector, or if you are creating any other extension that requires connection to an external service, you need to implement a connection provider, because it does, as the name suggests, it provides a connector, right? A connection, and that's what it does. It provides a connection to whatever service you're creating that connection to. Again, when you implement this, there are three possible classes, two possible ways that you can actually do. You can create a pooling connector provider, a cached connection provider, and a connection provider. Typically, you would want to create and use the pooling connection provider, because this actually just pools the connections and allows them to be reused. But you have other options, such as lazily creating those connections and caching them, and then, of course, creating a new connection each time it is required. So again, this is really normally only required when making external connections as part of the extension that you've created. So as part of this, you have to implement the connect method to make the connection, and of course the disconnect method as well. And curiously enough, there is a validate method. This validate method provides the logic for the test connection feature that you see, right? So you've used that many times. You've hit that button that says test the connection to my database, and it comes up with test connection successful or test connection failed. Well, you get to implement the functionality that makes that button work as well. That's part of the connection provider. But as well, of course, as part of this, you get to also as part of the provider, you are able to specify the requirement, the actual parameters that you require. So as part of this interface, part of the global elements, you can provide the parameters. So here I'm asking for the AWS access key and the AWS secret key. I'm identifying it as a parameter and saying that this is a password. So you can see that when it renders in the GUI, it renders as asterisks. Okay. So what about the connectivity logic? Well, the connectivity logic is provided in your connections class. In the connections class is used by the connection provider. So the connection provider instantiates the connections class in order to be able to create a connection. And in the connection class, as you can see here, what we've got are the Java code for making a connection to AWS. So in this particular instance, we've got an AWS basic credential. So we're creating credentials using the access key and secret key that was passed in by the user of this extension when they created and configured the Mule application. And we go ahead and we execute the appropriate code, as you can see here, to make that connection. So if you are connecting to a database, this will be database connection. If you're connecting to Redis, this will be Redis. If you're connecting to Google services, this will be Google logic. So whatever is required to make the connection, it's encapsulated in the connection class. Then the operations are those things that you want to execute. Those are the things that you drag and drop and put into your flow. So when you're talking about a database, it's going to be the select. So we create those in the operations class. So for the AWS endpoints, we have a single connector which calls text to speech. And what this does is it captures the connector configuration, it captures the connector connection, and with that information, it's able to instantiate a call to the downstream system, in this case AWS or the database or whatever it happens to be, and execute whatever logic is necessary in order to make that work. So if you're calling SQL, if you're calling an SQL database and you're passing in the query, you'd have to execute the logic that executed that query. So when you're configuring that graphical user interface, it is rendered directly from this class here, which is the operations class. So what we're going to do today is actually use a router. Router is kind of like an operations, really. It's referred to in the annotations on the entry point as a operation. So we use the operations annotation to refer to the circuit breaker class. So this class, again, it does provide an operation. You have to drag and drop something into your flow in order to be able to configure the router. So it does create as well the actual operations too. So we can see here that when you create the method, there's the method for the circuit breaker that actually executes the circuit breaker logic. We provide a display name and accept certain parameters. In this case, what we're doing is we're asking for certain parameters. For example, we're asking for the circuit breaker ID. So we have a unique ID for this particular circuit breaker. Imagine you want to have 2, 3, or 4 circuit breakers with different configurations in a single application. That is a possibility. Then we ask for what is the closed error threshold, the closed refresh period, and the open period. Here, what I've done is oversimplified the circuit breaker to make the implementation much easier. We then also need to make sure we pass in the routes. So we're going to create different routes, right? So we're going to create an open route and a closed route for our circuit breaker. So the closed route, of course, is when everything is working perfectly and you execute the request to the external system. The open route is when things have gone wrong too many times and you've made sure that you're no longer calling that downstream system. So we need to create the routes. Now, the routes really are just super simple. It's just a class which extends the route, and that's it. You don't have to provide implementation inside any of those routes. That can be completely empty. Now, of course, you can provide implementation. It's an alternative way of implementing the processor chain. Can be implemented and processed inside the root if you wish. I'm not going to do that today. I'm actually going to keep it all in one class. I'm going to keep it all in the circuit breaker method. Okay, so that's pretty much a quick overview of how you create an extension. Okay, how do you create a connector? How do you create a connector? How do you create a route? So let's have a look now at today's use case. We're going to use a circuit breaker. And for those of you who are perhaps not familiar with how circuit breaker works, I'm just going to go very quickly through how it works. So what's the idea of a circuit breaker? So the idea of the circuit breaker is that we know that distributed systems are guaranteed to fail at some point. No one ever guarantees 100% uptime, not even Amazon. They just say 99.99%. So they know that they can't provide 100% uptime. So we have to accept that as a reality. Of course, there are going to be invocations that are unsuccessful. There are going to be connectivity issues. Quite often, these faults are just transient faults. They tend to self-correct themselves after a certain period of time. So when that downstream system is offline or is not contactable, there's absolutely no point in trying to call that system again. So the way the circuit breaker works is that it tolerates a certain number of failures over a specified period of time. And then when it reaches that threshold, it opens the circuit and does not send any further requests to that downstream system. Now, this, of course, is beneficial because it then allows the downstream system to recover. Because if you're constantly bombarding that downstream system with requests, that could actually be the problem. So it blocks requests going downstream while the circuit is open. Then what happens is it half opens. It sends a kind of test invocation. So it sends one invocation to see if that invocation is successful or not of the downstream system. If it is, well, then it closes the circuit and allows for the circuit break. It allows for invocations to continue. If not, then it remains open. Now I'm going to simplify this for today. Okay, I'm going to make a simplified version. It only has two states. Okay, only has today's circuit breaker has two states: closed and open. All right, so either it's closed, which means everything is working well and the downstream system is not broken, and open state, which means too many errors have happened in the time we've configured, and it remains open for a certain period of time before it gets back to closed again. And that's it. There's no test or half open state. So I've kept it nice and simple to keep the implementation simple for us today. Okay. Oops. My next slide is not working. Ah, yeah. There we go. Yes, live coding, folks. Okay, so buckle up. Let's do a little bit of live coding. So, folks, just want to see, does anybody have any questions in the chat room that hasn't been answered yet? Let's have a look.
Yes, we have 3 questions in the Q&A section.
Okay, if you can identify them for me.
The first one is from Tony. Is for each component a scope or a halter, or neither?
I'm not sure I understand that question. Hang on, can I see it there? Oh, is for each component a scope or a router? Good question. I don't know is the simple answer to that. I have absolutely no idea. It could be
scope, right?
Yeah, I think it's a scope. I think we define it as a scope inside. I think we define it as a scope in the palette. It's not defined as a router in the palette, but its actual implementation, I don't know. I would imagine because it's defined as a scope in the palette, it is actually implemented as a scope rather than a router. But that's a good question. I suspect it is a scope, but I don't know for sure. I would have to dive into the Mule Runtime and find out. So next one, how do we debug and unit test connectors? Yes, they are a very good question. Trial and error, pretty much, to be honest with you. There is a unit testing framework that we can use. I have to admit, I haven't used it. And I was hoping to be able to demonstrate it to you today, but unfortunately, I didn't get it working. So I'm not going to be able to demonstrate it to you for you today. I suspect what we can do is we can have another meetup about debugging and unit testing connectors. I think that might be quite useful. So that might be an idea for a future meetup. All right, so good idea there. And the next one is logger component or connector, as it performs operations and also forwards to the next operation. Similar question with transform message. I would imagine logger is a connector without any connections. I'm not sure what it is underneath the surface. It could just be a component. It's a component, of course, but I think it might be connector type component rather than a scope component. Could be a scope component. I'm not sure what it is actually implemented as underneath the surface. But again, good question there. So let's take a look at a live coding example. So I'm just going to cut that down there, and I'm going to open up Anypoint Studio. So I'm going to be doing coding in Anypoint Studio, folks. So I've configured Anypoint Studio to do Java development, and I'm going to create a completely new workspace for this, which I'm going to call Circuit Breaker Live. Okay. So if you want to know how to prepare your studio for Java development, then you could read this blog article which I wrote, and I'm going to shamelessly plug it to everybody. So I'm going to put that in the chat window. So if you want to set up Studio for Java development, these are instructions on how to do so. So I'm just showing you this while Studio opens because it takes a few moments to do so. Okay, and on this and on my blog, you will see various articles also as well about working with Mule and Java. Okay, so here we go. If you want to see how to build an Amazon Poly connector in 15 minutes, well, there we go. There is a link right there. Okay. So let's have a look. Studio is open. It's looking good. I'm just checking to see. Yep, it's okay. Right. So we're going to create the we're going to create a new project, but we're going to create a new. So we're going to go to File, New, and we're going to go to Other, and we're going to find Maven project. We're going to create a new Maven project. Okay, go to Next. All right. Then we need to search for the right artifact. So the right artifact is called org.extensions. No, it's not. It's called org. Excuse me. It's called org.mule.extensions. Okay, and this is the one we want, the Mule extensions archetype. We're going to go to the next page. So the next bit is rather important here. So I'm going to set the group ID. So the group ID is going to be in my case, it's going to be my organizational ID. So I'm going to set the group ID there. I'm going to set the artifact ID is just going to be the name that I want, which I'm going to be calling it Circuit Breaker Simple, for example. Okay, and I'm going to change that down here too. The package, I'm just going to call the package circuit underscore breaker underscore simple, like so. All right. Then the extension name is going to be a human readable name. So we're just going to call it circuit breaker simple because this is a simple circuit breaker. And then the final one, which is the extension name, no spaces, is the same thing, but without any spaces. Okay, so what this will do is this will create the project structure for us. Let's have a look. Just want to make sure it is building that. Okay. Takes a few moments. Has it built yet? Still waiting there. Okay. I'm just checking, discovering lifecycle methods. Ignore that. Okay. All right. So let's take a look at what it's done. So what it's done really is just create some files, right? You can actually create this manually if you really wanted to. So let's take a look at the POM file. So it hasn't really done much in the POM file other than the fact to reference the parent as being the Mule module as the parent. So this is the parent. So it takes various dependencies from that location. Okay, so there's nothing particularly fancy going on in there. Then it's created all of these configuration files. So we don't need most of these files actually. So we're not going to create any kind of connector. So I'm going to get rid of the connector and the connector provider. So I don't need those files. Okay. We're not going to create any operations explicitly. So I'm going to get rid of this operations file. So I don't need that operations file. So we're just left really with these two files here, right? So I'm going to need to correct the errors here. So I'm going to go into my circuit breaker simple configuration. And in this file, okay, I'm going to switch to the Java perspective. Yeah, there we go. I don't need any of these configurations, so I'm just going to remove all of those. And I actually don't need any of those configurations. And I'm going to remove all of these extensions. Okay, so I'm just really stripping things down to the bare essentials here. Okay, so we're starting really with almost nothing, right? But we're going to start here at the entry point. This is the entry point to our application. Remember, I said that this extensions class, this is where we create the annotations that point to the classes that we want to include in our extension. Okay. So the first thing I'm going to do is with the XML. What do I want the XML to look like? Well, what I want the XML to look like is this. Okay, prefix equals CB. So when the XML is created in the actual Mule application, CB is going to be the tag that is going to be used. Extension name as a sensible name here for the extension. And then we have some configurations. So we need to create some configurations. This class is actually executed during instantiation. So this is where the lifecycle methods are going to be implemented. So I'm going to add here also as well the actual router, it's the router class itself. So I'm going to add in operations. So let's see if this auto completes. Yes, it does. So I'm going to create a new class called if I could spell, circuit breaker router class. Okay, so I need to have the operations annotation, because this relates to what is effectively the operation. So everything that you drag and drop and put inside your flow is from the perspective of an extension is an operation. So if you're creating a connector, then the logic that we've created a connector, then the operations for the connector have to be referenced here inside the operations class. If you're creating a router, then you need to reference the class here as an operation. So everything that you drag and drop and put into a flow is, from the point of view of an extension, actually technically an operation. So I'm just going to create my circuit breaker router class. So I'm going to let it create that for me automatically. Okay. Okay. So the next thing I need is I need to create routes. Okay, I need to create some routes. So we're going to have two routes, right? Open route, right? We have the open route and we have the closed route. So I'm just going to create two routes. So I need two classes representing those routes. So I've got one called closed, closed route, right? My closed route. And here I'm just going to extend the root class. Is it going? It cannot auto-complete. It's not doing it for me. Ah, okay. Never mind. If I save it, it was doing it for me the other day. Come on, autocomplete. Ah, there we go. Well done. There we go. So it's found it for me. There we go. And I don't need to provide any kind of configuration or anything in this class. I can do if I wish. If I want to process the event, if I want to process the chain, that's the chain being the event processes inside the root, then I can process this in here. I'm not going to do that. I'm actually going to do it in another place, which is going to be in the operation itself. Here, I'm going to also create another class. This class is, what's it for? This is going to be the open root. So exactly the same thing here. I just need to extend the root. Okay, so nothing fancy really going on here at all. But we need this, right? We need to be able to have a way of representing the roots in some way, right? This autocomplete there. Excellent. So I'm just going to tidy up this class. As you can see, it's lovely and empty, right? Nothing going on there. So we're going to be referencing those and passing those into the operations a little bit later. So in the operations class, this circuit breaker router class, this is where I'm going to be managing the actual routes. Which route am I going to be executing? Am I going to be executing the open route, or am I going to be executing the closed route? All of that logic is going to start from within the operations class. So I need to add some helper classes. So I'm going to add in an enum. Okay, actually, I'm going to add in an enum. I'm going to call this enum CB state. So that's going to be the circuit breaker state. So the circuit breaker state is going to be either open or closed. So I'm just going to create a very simple enum. Okay, this makes it nice and easy to record what the state is. Okay, so I've got that. Okay, I'm just going to keep that open so you can see, very simple. Then I need to create two further classes, which I'm going to implement. So I need a class that represents the instance of the circuit breaker. Because remember, what I want is to create multiple circuit breakers in one single Mule application, potentially, because I might be calling 3 downstream APIs or 4 downstream APIs, and each one requires a different configuration in relation to the circuit breaker, right? So I want to have 1, 2, 3, or 4 circuit breakers configured for a single application. So I need an object. I need a class that I can instantiate 4 times for each one of those circuit breakers. So I'm going to create a new class. I'm going to call this new class circuit breaker. So this is going to be what the circuit breaker looks like. So this is a circuit breaker. Okay, like so. So at this moment, I'm not going to provide any implementation for this class. I'll come back and I'll provide some implementation a little bit later. Then I need another class, which is going to actually encapsulate all of the logic that calculates what the current state is, because we need to dynamically calculate the number. We need to dynamically calculate the period of time that has passed since the last open or closed period started, because we're going to be operating on periods of time. So for every 5 seconds, 3 errors can occur. If more than 3 errors occur in a 5-second period, then we open the circuit, because that's too many, because clearly the downstream system is broken. Then we keep it open for a certain number of seconds, say another 5 seconds. So we've got to be able to measure that period as well. So we need a class that processes the state and provides all the logic for processing the state, determining what the current state is, for calculating how many errors have occurred, for resetting errors when they reach the threshold, and so on and so forth. So all of that processing of the logic of the actual circuit breaker is going to be encapsulated in a single class. Okay. Now, we could extract this out into multiple different classes and do it differently, but just for simplicity purposes, and of course, this is not about the logic, this meetup is not about the logic of a circuit breaker. We know that. It's about how to create routes. So I'm going to encapsulate it all in one single class, which I'm going to call it state processor. Oops, processor, like that. So I'm going to do state processor. Okay, so there we go. In his class, I'm going to be implementing all of that logic. Right, so there we are. Now we have all the classes we need. Let's get to the implementation part. Okay, I'm just going to delete this from here so we got a little bit better space, and then minimize that. There we go, that's better. Right, let's dive in now to start implementing our actual logic. So the first thing I want to do is to go and have a look and think about the lifecycle methods that are provided to me that I can then hook into. So I'm going to go to my circuit breaker simple configuration. And here I'm going to start implementing my lifecycle methods. So I just implement. So I want to implement initialize, for example. Let's have a look and see if it auto completes. Come on. implements needs to be implements. Let's see if it does autocomplete. Come on. There it is. Initializable. Okay, lifecycle event. Excellent. Well, thank you very much, Studio. You've done a good job there for me. The next one, I'm actually just going to I'm actually going to put all of the lifecycle methods here, even though I actually don't need them, but I think it's actually rather important, and to be able to have all of these methods here just for demonstration purposes. I'm only actually going to implement one of these methods, but I want to be able to make sure that we are aware that these methods exist, and we can hook into these methods. There we go. So I'm going to add unimplemented methods. There we go. Fabulous. Right. So we have a stop method, we have a start method, we have a dispose method, we have an initialize method. So of course, the initialize method is a method that is called when the Mule application initializes. Okay. So I'm going to implement only this method. I'm not going to do that yet. I'll do that in a moment. But this class is the class where we take the opportunity to start injecting services. So we can inject, for example, in this case, I'm going to inject the object store. Oops, object store. Hang on, if I could spell object store manager. There it is, object store manager. Okay, we're going to implement the object store manager. That's going to go OSM. There we go. All right, and then I'm going to let it complete for inject. Yeah, that works. Okay, what I'm going to do in the initialize method, I'm actually going to, let me bring this method up to the top of the screen, because this initialize method, what I'm going to do here is I'm going to take the object store manager, I'm going to pass it into, and I'm going to set it as a static value, okay, on my state processor. There's only one object store manager. That object store manager manages all of the partitions and all of the object stores, effectively manages all of the object stores that you've created for that particular application. Therefore, it's perfectly safe to inject that in, to set that as a static value on the state processor. Now, we're doing some things here, right, that might feel a little bit uncomfortable, but it's the nature. Using static classes is always a little bit uncomfortable. I'm never really happy with that. I prefer injecting things into classes and doing things that way. But you know, this is what we're provided as a way of being able to operate. So what I'll do next is I will go to the circuit breaker simple router, the circuit breaker simple router, and start implementing this. So remember, this is the operations. So this is what I want to drag and drop and put into my flow and provide the configurations for. So here I'm just going to create a method, right? So I need to create a method for this class. So just bear with me while I actually remember what it is that I've got to do. So I need to create a method. The method that I need to create allows me to be able to actually implement the logic for processing the actual circuit breaker itself. So this is going to be a public void, or public void circuit breaker. I call it circuit breaker. Okay, simple method, nothing fancy yet. I'm going to provide it with a display name. Okay, and the display name is going to be what is actually displayed. So I'm going to call this one circuit breaker. Okay. Right, so what happens inside here, okay, is this is where I am going to be passing in parameters. So inside the method, this is where I start passing in my parameters. So one of the first parameters that I actually want to care about, and I want the user to configure, is going to be the actual circuit breaker ID. So the developer has to provide a unique ID for the circuit breaker. Now, we could probably improve this by auto-generating this. So bear in mind, this is actually a simple implementation, so we could improve what I'm doing here quite substantially. And actually, that's one of the challenges I'm going to set for you, is to take my code and make it better. Okay, there's lots of things you can do to improve it. So we're going to call this is going to be part of the actual graphical user interface. Is this message is part of the graphical user interface and asking for a circuit breaker ID. So we need to go ahead and we need to provide things such as the closed error threshold. So how long is it going to be closed? What's the refresh period? How many errors? Sorry, the closed error threshold is how many errors can occur in a certain period of time. That's the closed refresh period. And how long are we going to keep it open? So I'm going to just copy and paste some code here that represents that. Okay, hang on, that didn't work. There we go. So we have this optional, okay, which allows the this to be optional. Actually, I'm making it optional because I'm providing a default value. So this is for the error. So I think 5 errors is enough. I'm going to wait 5 seconds, okay, until I reset that errors to 0 in the closed state. In the open state, I'm only going to stay open for 5 seconds. These are the default values, but they are highly configurable. I also as well need to pass in, okay, I need to pass in the closed root, okay, as well, right? I need to pass this in, right? I also need to as well pass in the open root as well, okay? Okay, and also as well, I need to pass in, and this is important, is the router completion callback. Okay, let's call it callback. Okay. So the completion callback, what this does, this callback is how the router receiving routes can notify of their outcomes. So we're going to use this callback to notify of the outcomes of a given route. All right, so we've got the configuration options set. Let's move on and have a look at how we're going to be handling this. So we're going to make sure, we need to make sure that we have the state. So we need to make sure we have the state, okay? And I'm just going to set the CB state to closed temporarily. We're then going to use a switch statement. Oops, we're going to use a switch statement. Let me just make a little bit of space down here. We're going to use a switch, okay, which is going to switch on the state. So depending on the current state, all right, depending on the current state, we're going to execute one route or another, okay? So it's based entirely on the current state, okay? We can improve this, of course. We're making the assumption that our application is used frequently rather than once every 2 hours. So we're assuming that our application is actually used quite frequently. Oops, no, that's wrong. Actually used quite frequently. Okay. And then we do this, and then we do this. Okay, so oops, like this. Okay, so there's the closed state. I'm going to do the same for the open state as well. Okay, and then of course we've got the default state. It should actually autocomplete. There we go, default, there we go. And the default state, which should never actually get executed. Okay, so this should never actually happen. Okay, oops, I missed out. Code on there. So the default state should never really actually get executed, right? But we're going to put one in anyway. Okay, so this is a skeleton of what's happening. So every single time my Mule application is executed, this method gets executed, right? So every time my Mule application is executed, this method is executed, and we decide what the current state is. We determine what the current state is. Based upon the current state, we execute either this one or this one, the closed route or the open route. All right, so I'm going to switch to I'm actually going to switch to the state processor now, I think, because actually what I'm doing here is what I really want to do is I want to call the state processor. All right, I'm going to call the state processor, and what I want to do is I want to call a method in the state processor, all right, that determines the current state. So determine cb state. Okay, this method doesn't exist, so I'm just going to create that method. So create method. Okay, so it creates a nice static method for me, which is fantastic. Okay, what I need to do here in this state is actually use this determined state. First of all, I've got to make sure that I can actually create an instance. So if the current execution is the very first execution, I need to make sure I create the circuit breaker instance and store it in the object store against the circuit breaker ID. So what I need to do here is I need to pass into my circuit breaker. I need to pass in some values. So I need to pass in effectively these values up here. Let me just get rid of that. I need to pass in the circuit breaker ID. Okay, I need to pass in the closed error threshold. Okay, this is closed error threshold. I need to pass in the closed refresh period. Okay, closed refresh period. And I need to pass in, oops, I'm going to just bring that down on the next line. I need to pass in open period as well. So this is what I need in order to configure the circuit breaker, right? So again here, I should have probably, let me just see if it's going to remove arguments, change method to this. There we go, create method. I'm going to create a method. Actually just creates that method. I'm just going to delete this one here. There we go. All right, better. That's better. It's much better. Okay, so here we go. This has created that perfectly. Let me just remove that from there. So there we go. So what do we do when we go in here? Well, the first thing we want to do is we want to be able to create a circuit breaker itself. Well, actually, we don't. What we want to do is we want to test to see if the circuit breaker with this ID actually exists. Well, that's stored in the object store, and the object store is here, right? Well, what I want to do is I want to go to my instantiation, or when my application instantiates, it calls this initialize method, and in this initialize method, I want to call the state processor again. Oops, I want to call the state processor. Okay, and I want to set the object store manager. So I'm going to place object store manager. There's only one object store instance, so this is perfectly safe to do something like this. Okay, I want to pass in the object store manager that I've retrieved here into my static. I want to do it statically, so I can set it as effectively set it as a global. So I'm going to create the field. So it creates the field for me. Fabulous. Okay, so now I have an object store manager in my state processor. So with the object store manager, what I can now do is I can now access the object store. So what I'm going to do is I'm going to take the object store manager, okay, object store manager, and with the object store manager, I have a whole variety of methods. This is great, right? This autocomplete really actually helps substantially. So I can actually obtain the object store, right? Object store itself. Well, I'm just going to get a petition. Okay, I'm just going to get the default petition. I'm just going to use the default petition. Now, one improvement that you might want to make is to allow the user to create their own object store and to configure that in the global configurations for the circuit breaker. Now, I haven't done it here for simplicity's reasons. I'm just getting the default petition, which is perfectly okay. So I need to get the default petition. All right, I'm going to store this, okay, as the object store. Okay, and this is going to be my object store, which is going to be OS. Okay, so I need to insert that object. So we have a slight issue here. One thing we need to do is we need to add type arguments to the object store. Okay, that's fine. So we add type arguments, but the type that I want to store in the object store is going to be type circuit breaker, right? So this is another important thing we need to make sure we do correct. Okay, so there's my circuit breaker. we have a problem. Look at this, right? Bond mismatch, the type circuit breaker is not a valid substitute for the bounded parameters. Well, why? Because it doesn't extend serializable. The object store, any object that is stored in the object store must extend from serializable. Okay, so, well, in that case, let's go and make that happen. Let's go back to the circuit breaker object and let's go and just do that, shall we? So we're just going to implement serializable. There we go. All right, and let's just go ahead and just add that. There we go, just to keep it quiet. All right, so there we go. So there we go. That's fine. Now that works. It is now happy. Okay, it is now happy because my circuit breaker extends serializable, which is a requirement of storing objects in the object store. So let's now take a look back here at the rest of this method that we need to implement. So we now have the object store. This is great. So now what we can do is start implementing logic to help us build out this method. So I'm going to actually copy and paste quite a lot of logic, because really what the logic does here is not the main purpose of this session. So I'm going to copy all of this and I'm going to talk to you about it. Okay. So I also need to provide, I'm also doing some logging here as well. So let me just put in a logger. Give me 1 second while I do that. Okay. So I just need to make sure I also include all of the classes that I need. Okay. There we go. Superfluous there. Okay, we don't need that one. No, we don't need that one. Okay, so let's take a look here. So there are a few things that I need to fix. Okay, so let's take a look. So what am I doing here? So the first thing I need to do is object store contains. Okay, so literally when you use the object store in a Mule application, right, and you drag and drop the contains operation into your flow, well, this is the method it actually executes, is this method here, right? And I'm using that method inside my applications. That's pretty cool, right? So I'm passing in the circuit breaker ID, which I'm using as the key that references the circuit breaker object. And the circuit breaker object contains the configuration for the circuit breaker, plus it maintains state around invocations, state around the period of time that has elapsed since the last circuit breaker was executed. So this is why we're seeing all of these errors here, because I haven't implemented methods inside the circuit breaker. So if the circuit breaker exists, well, then I can go ahead and I can calculate what the current state is. If the circuit breaker does not exist, well, we just create a new circuit breaker. Okay, so there we go. We can just create a new circuit breaker. So I'm going to go in here and I'm just going to create a constructor in the circuit breaker like so. So again, here with the circuit breaker, I'm just going to, and it's a very simple POJO, it's really not a complex method at all. I'm just going to copy and paste the code for that and talk a little bit about what it does. Hang on, bear with me 1 second. Okay, so let's take a look. All right. So again here, let me just resolve these things. So what do we do here? Well, we're keeping time, right? So we've got the circuit breaker ID, we've got the CB state. What's the current state? So by default, it's going to be closed. So the start state is always closed. Time since epoch. So I'm just using a very simple way of calculating how many milliseconds has passed since the 1st of January 1970. And I'm using the difference between the last time I stored that value and the current time to work out if 5,000 milliseconds has passed. It's a pretty crude way of working it out, but it kind of works, right? And it is effective. So there we go. Time since epoch. So the current time since epoch. So the time that I'm creating this is what I'm storing inside time since epoch. So what else do I have in here? I have the error count. So the number of errors that have been occurred. I have the current state, time since epoch. Okay. I have a method here that it just increases the error count. it sets the error count, so we can reset the error count to 0 if necessary. And yeah, that's all we need. Okay, so I'm going to save that. So the circuit breaker class is just a simple Pojo representing the circuit breaker. Let's go back here into my state processor. So we've created here the circuit breaker. So we've created the circuit breaker, and now I'm storing, calling the store method, storing the circuit breaker against the circuit breaker ID as a key value pair in the object store, and then just returning a closed state. Let's go to the top and let's walk through the logic here. I'm just going to resolve this. Okay, so very quickly, what's the logic here? So if the object store exists, then what do? We retrieve the object store. If the circuit breaker exists in the object store, then we retrieve that particular circuit breaker. So there we got the circuit breaker. So we get the time since that has expired since epoch. We get the current time. What's the difference between time since epoch when this was last updated and the current time? Well, there we go. There's the time elapsed since last status check. Then based upon the current state, which as an initialization state is closed, based upon the current state, we do a check. So time elapsed since status check, if that's more or equal to the close refresh period, then we need to set the error count to 0, reset the time since epoch to now, and then we need to update the CB object in the object store. So we then need to save that circuit breaker object back into the object store. So we'll have a method just for doing that. And then we just return the closed state. Again, here, if the error count is more than or equal to the threshold and the current state is closed, what that means is we have to return an open state. So again, we update the circuit breaker object, and we restore that back into the object store to be used next time. And then we have a default return of just closed. This should never get executed. Then we have an open state. So if the state is open, then we need to check to see if the open period has expired. So what's the time elapsed since the last status checked? If that's more than the open period time, well, then we need to close. Okay. Otherwise, just return open because it should still be open. Okay. Okay. And then the default case is just there. Just put a log in there. And that's it, really. There's not much more. So there are a couple of methods down here. So we got one that updates the object store and then one that increments the error count. Okay, so this increments the error count. Right, so that's the state processor. Its job is to calculate what the current state should be to calculate the current circuit breaker state based upon the various parameters, and then to update the circuit breaker object to restore that in the object store for next invocation. So it's constantly updating the object store to be able to do this. All right, so let's go back to the circuit breaker router, and this is where the magic really starts to happen. So this is where we need to create an implementation that is very specific to the way in which routers work. So we need to go into the closed route. Okay. And what first thing we do is from the closed route, we need to get the chain. Okay. So what this does is it gets the event processor in the closed or open route. So in this case, it gets the event processors in the open route. Okay. So once you've got that, what you then need to do, okay, is to process it. You need to process it. And there are 3 process methods. I'm going to use the first method here. So what this then does is it executes the events in that route. So what I'm doing is I'm saying the state is now closed. Therefore, what that means is I have to execute the closed route and all of the processes in that. And this is what I'm doing. I'm getting the closed route. I'm getting all of the processes in the closed route, and then I'm executing them. So I'm getting the event processes themselves. So I'm really manipulating how the Mule application is actually processing the events the event processors inside the actual routes. So this is pretty exciting. I'm really going down deep into the Mule runtime here. So I'm going to process this. So this takes two parameters. So the first of all, it takes a consumer. So I need to provide it with the need to provide it with the callback. Okay, so if it is successful, then all I need to do is call the success method, right? So if there are no errors, right? If there are no errors while that route is executing, while those processes are executing, everything is fine, and I just call the success method to notify the callback, to notify via the callback of success. And then the Mule application continues processing with the rest of the flow. However, interesting part comes here is we now have a by consumer, which is responsible for handling the error. And this is where we kind of effectively capture the error. We don't really capture the error, but this is the logic that we want to execute when there's an error. And when there's an error, we want to increment the error count, right? That's what we kind of want to do. So it has two parameters. Of course, it's by consumer. And in here, I'm going to provide an implementation, bear with me, like so, of the logic that I want to execute. Let me just tidy this up a little bit. So what I want to do here, I'm just going to put a there just to get rid of that error. There we go. So now when there is an error, what's the logic I want to execute? Well, the logic I want to execute is to call the state processor. Okay. I want to increment error count for this circuit breaker ID. This circuit breaker ID. Okay, so of course in this logic, what you'll see here, if I go into this method, it's not taking me into that method. Let me save this. Okay, it's not taking me into that method. Let me, I need to probably do that. Is that why it's not working? Ah, yeah, there we go. Okay, it's not letting me go. Okay, I'm going to go manually. There we go. So it's going down to increment error. So what it does is it gets the, it's got the object store default permissions, got the object store, retrieving the object store circuit breaker, calling the increment error count, and then storing that object back in the object store again. Okay. All right. And then what do? Then I have to notify, the runtime that an error has happened. So I've got to call back, and I need to basically just throw the error back. Okay. All right. So that's what happens in the closed route. Well, pretty much the same kind of thing happens in the open route, because of course in the open route, what we're doing here is going to open route. Okay. Then we've got the get chain, we've got the processor, which is this one. Here, I'm just going to use the callback, because here, if it's successful, okay, full success, all right. And then if there are errors, again, I don't really want to do very much, because this is really the kind of like the default route, because nothing really is going to happen here, okay. Perhaps I might want to, implement some other kind of logic here, but really I'm just going to pass the error back. I'm not going to do anything fancy here at all. So just callback dot error, job done. Okay, so here in the open route, all I'm doing is just processing whatever happens to be in that open route. So probably going to be a logger or something like that. So I'm not really expecting any errors to happen. And if they do, well, then I'm not going to be handling them and dealing with them inside this logic here. I only care about errors inside the closed route. That's where the errors matter. That's what I'm monitoring here. Right, so that's it. Okay, that's it, folks. All right, we've done it. We've implemented the router. This is actually, okay, this is actually the implementation of a router. It is actually remarkably simple. Most of the work is actually in here. Actually, the actual logic of calculating the state of the circuit breaker is actually inside the state process, and really has very little to do with the actual calling of the route itself. It's really very simple, just calling this process chain to execute it, and then handling and then updating the error state, the error count when an error occurs. I think that's it. Yeah, let me check. That's it. There is one more very important thing that we must do. Now, this is probably the most important thing that we must do every time we create a component or an extension. We have to add an icon. We can't live without an icon, can we, folks? We've got to have an icon. So this is probably the most fun part, certainly the bit I enjoyed the most, was searching the internet for a suitable icon. I found a suitable icon. You'll see it in a moment when I get to actually use it. Okay. So let's have a look. So the icon is what the actual component looks like when you drag and drop it and put it in the flow. That's why it's the fun bit. All right, folks. So what happens next? Yes, I need to, first of all, before I go, it does automatically generate some unit tests. All right. Okay. And you can have a look here, and you can have a look at how unit tests might operate. But I'm actually going to delete these because they don't relate to the circuit breaker. They are the ones that automatically generated. So I need to delete those. Then I need to run this in Maven. I need to go to my command line. Okay, so I'm here. I'm going to go into here. I'm going to go to CMD. I'm going to execute this. Let's go up here. Oops. Then I need to do mvn clean install. I'm just going to install it into my local repository. I'm not going to install it into Exchange. I'm just going to run it on my local repository. Okay. Fingers crossed, folks, because I haven't run this before, so there could be all kinds of horrible errors. Oh, good. That looks okay. It hasn't broken, which is always good. Right, let's have a look. I'm just looking at the bottom of my screen there. Come on, tell me that. Yeah, we go. Oh, phew, fantastic. Right, build success. Wonderful, the most joyful words that we can have. Right, so, okay, well, let's just go and close down this project because I don't need this anymore. Actually, no, that is not true. I do need it in a minute. Let me just open that again. I'm going to now create a new. So I want to create a new, oops, I need to go here, new project. I want it to be a Mule project, Mule project. This is going to be circuit breaker, simple, API, I don't know, whatever, something like that. So that'll do. So I'm just going to create my new Mule project. All I need to do is actually put in the Maven dependency into the POM file, and that will bring in that dependency from my local repository. So when Studio wakes up, we'll be able to do that. So the next bit is going to just be another 10 minutes, and we should be finished. Okay, there we go. Do you want to change to design view? Yes, please. All right, so this should be familiar to all of us. Let's go into our POM file. Okay, I'm just going to add in the dependency. So I'm just going to copy this here. Okay, I don't need that. I'm just going to remove this because I'm just going to cheat, and I'm going to go into here, go into this POM file, and then just copy this from here. Okay, there we go. And now I can close down my Java project because I don't need that anymore. I can save this. So as soon as I save the POM file, this should resolve that dependency. There we go. There's my circuit breaker, folks. There it is. Look, it's inside my project. And look, there's my circuit breaker. There's my jar file. Okay, and there's all of my classes, right? They've all been compiled and ready to go. And you can see, look, there we go. Can you see there? You can see the icon for my circuit breaker, right? So I need to close that down. What do I need to do? Well, a couple of things that I need to do. There is a dependency on the object store. So I need to add the object store. Okay, so I need to add the object store. Okay, I'm also going to add the validators because I'm going to use the validator to provoke an error. So I'm going to add the validator as well. I also need to go to my global elements, and I'm going to create a global element configuration for this. Now, in this particular instance, there's no configuration here because this is a really simple implementation, and I need to add this configuration into my project to bootstrap my classes. Otherwise, it's not going to work. Otherwise, my circuit breaker is not going to initialize. I need to do this just to simply bootstrap this. Now, in a more sophisticated implementation, what you could have here in these global configurations is the ability to configure an object store, or perhaps not an object store, perhaps some kind of other connection to some other system of some sort that you use to store state. So I'm just going to add that in there because I need that in order to bootstrap my configuration classes. Did I click OK? Yeah. Okay, so that's done. Fantastic. So now I can go back into my project. I'm going to take an HTTP listener. So there's my HTTP listener. I'm going to drag and drop that into my flow. So in order to evoke this, what I'm going to do is I'm just going to create a very simple endpoint for this. So I'm going to just add a connection configuration, click OK, set the defaults, that's fine. And my endpoint is going to be test. It doesn't need to be more than that. Now comes the fun part. Let's go and have a look at the circuit breaker, because there's the circuit breaker, right? We can now see it's in our project. Oh, I want to move that along. I can't move that along. There we go. So there's my circuit breaker. Look, there's my icon. There's my circuit breaker. There's my circuit breaker operation. I can drag and drop that. There we go. Hey, look, there's my icon. That's the fun bit, right? So there's my icon, folks. There it is. That's what I spent hours searching the internet for. What I need to do now is provide the configurations. And hey, look, this is a circuit breaker instance ID. Does this look familiar? And there's a circuit, there's a closed error threshold, there's a closed refresh period, there's the open period. We know where that came from, don't we? It came from that operations class that extends the router, right? Or the operation class that's called router, that router class, right? So I'm just going to put a unique ID, okay, for my my circuit breaker. Now, of course, if you wanted to improve this, you could have some auto-generated ID, for example, right? But I just made it manual. Okay, so there we go. Now the little red icon has disappeared. So all I need to do now is there's my closed route, there's my open route. So I'm going to put some loggers in here. So I'm going to log, there's one logger, there's another logger. Okay, for this logger, I'm going to put in closed. Okay, and then for this logger, it's going to be open. And then what I'm going to do is I'm going to go to my validate. Okay, and validate, I'm going to choose is true. Put that there. And is true is false, so it's always going to error. So basically, the close route is going to error every single time I call it, which of course is precisely what I want, because when I call it, I want it to count the number of errors. Okay, I want it to count the number of errors, and I want it to count the period of time over which the errors occur. I want it to reset the errors to 0 when that period of time expires. And when that threshold of error count exceeds, I want the open route to then become executed for a certain period of time until it closes again, until the circuit closes again, and the closed route executes. So now, folks, is the real proof. Have I done this correctly? Let's run the project and find out. Okay, so I'm just going to expand this, and actually let's just go full screen, I think. So what you'll see here is I can point out precisely the points in the logs here where the Mule application initializes itself and starts, and that's where those lifecycle methods get executed, and you'll see that they happen before the application goes into service. So we've got the Mule Runtime there, it's up and running. And let me just open up Advanced REST Client. So here we go, I've got Advanced REST Client. So I've got Advanced REST Client here. Okay, I'm going to call this endpoint. I'm just going to put this on another screen so we can actually watch the logs. Okay. So let's see this deploy. All right, it's deployed. So let's have a look at the logs. I want to show you, here we go, initializing the application. This is where we initialize Okay, this is where we initialize the actual application. And there we go. We can see it's initialized. It's circuit breaker simple config. So we can have confirmation that it has initialized. Okay, we can put some logs in there if we want to. Then we have starting application. This gets executed when the start method on that file, on that class gets executed. All right, so I'm just going to clear my logs. Okay, let's have a look. I'm going to make one execution. All right, so let's take a look at what's happened here. So we have an invalid Boolean. Fantastic, right? So what's happened? We can see clearly creating new CB 1, 2, 3, 4, 5. Current state of the CB is here. Is the entire CB object. This is a toString of the CB object. So error count is 0. Current state is closed. Time since epoch. Okay, an error has occurred. Let me try again. So 5 seconds has, more than 5 seconds has passed since the last execution, which is why the error count has gone down to 0. But let me call a few more times and you'll see the error count increasing. Error count 1, error count 2, error count 4. Okay, now the state is open. I exceeded the error count. All right, I exceeded the error count. Now the state is open. State is open. It keeps opening. It's not executing the closed route anymore. It's executing the open route, because you can see no more errors are occurring. So now more than 5 seconds has passed. So the open route should have reverted back to a closed route. So the state is now closed. Let's test that. There we go. Another error is thrown, meaning the state is now closed again. And I can keep executing this. It will count those errors. And if I execute slowly, you'll see that it goes back to 0. There we go. Gone back to 0 after 5 seconds. Count 1, count 2, count 0. If I do it faster, count 1, count 2, count 3, count 0, gone back to 0. So it's every single time an invocation is made of my application, it recalculates the state for that circuit breaker. This is one of multiple ways of achieving this objective. Okay. Another way is using scheduled tasks running in the background in separate threads. I actually did an implementation like that, which you'll be able to see in my GitHub repo, which I'll share with you at the end. In my GitHub repo, what you'll see is there are 2 different implementations. One implementation using the method that I've used here, creating this static class that maintains state via the circuit breaker and the object store, and another one that uses scheduled tasks that run in the background and continuously monitor and update the state of the application. So that's it, folks. That's the end of that part of the presentation. So any questions? So question here, can the prefix contain a dash? Yeah, it can. Absolutely. If we have a look, actually, if we go and have a look at the XML, look, you can see in the XML, there's the CB that I specified. That's the CB that I specified in the extensions class. Okay, but of course you can have, I think you can have, I mean, I have seen it, but yeah, no, you definitely can have dashes. So this could be circuit dash breaker if you want it to be. And how does it look in the Mule flow? That's how it looks in the Mule flow. So where can you find the recordings? I think it's going to be published.
Yeah, it's going to be published in this same meetup page. So you see the recording tomorrow on this meetup page.
Okay, so I think you'll find it tomorrow if you go back to the same location. Okay. So just to finish off my couple of slides more before I hand it back. So challenge to you folks, improve what I've done, make it better. Okay, make it better. So what can you do? And I'll give you the repo link in a moment. So improvement ideas, implement the half open state. Okay, so implement the full pattern, right? Allow customization of the object store, i.e. don't use the default partition. Add in monitoring and alerting when state changes, right? If you look at what Netflix has done with their implementation of the circuit breaker called Hystrix, they've done a really amazing, sophisticated implementation. Try to have a look and see what they've done and replicate that. Have built-in retry logic for common transient errors, configure error-based state opening. So, for example, if you get a 404, then error immediately goes to open because there's no point in trying that. Okay, if you get a 503, it's transient, so retry X number of times, then open, something like that. So change the pattern slightly. What about creating other routes, right? So what about a fallback route? Retry invocations, then call another system if the threshold is exceeded. What about rate limiting and throttling? You can do that, okay? So downstream systems where it's not possible to use an API policy, maybe. So these are some ideas that I was thinking off the top of my head that you might want to try and have a go at. So question and answers. So questions and answers. Any questions, anyone? Or answers? All right. Here's the repo. All right, I'm going to send that through to you and put it in the chat window so you can go and grab all my code from here. So I've got multiple different examples. So I've got CB breaker multiple. That's the one that I did. I demonstrated to you today. And this other one, breaker simple. This was much a simpler implementation that I did a few days ago. I don't have any descriptions there, but you can just grab the code, fork the repo, and have lots of fun with that. Okay. And there are some useful resources as well that I recommend that you go and take a look at. So how to build an AWS Poly connector. So that was presented by Olga a few months ago. Please do go and take a look at this. I'm going to offer this is also as well in the chat window for you folks. Okay. Also as well, have a look at this circuit breaker as a custom API policy. So this is from Virtual Muleys, using the Mule for Java SDK to design DocuSign connectors. So this is another one from Virtual Muleys. And I did another one, Mule integration for Java professionals. That was months ago. Also as well, take a look at Vishwa's YouTube channel. He actually has an interesting implementation of the circuit breaker using a Mule SDK and Hazelcast. So again, if you want to see another way of implementing this circuit breaker, take a look at his YouTube channel. So I'm just going to pass this through as well. It's definitely worth mentioning. Oops. Oops, no, sorry, I'm not going to play that. Oh, hang on. There we go. I'm just going to get rid of that. There we go. So I think that goes through. I'm not sure if that's the right link. That should be okay. And that's it from me. That's all I have to say for today. Thank you ever so much for spending time with me today. I'm going to hand back to the quizzes and the trivia.